I don't know about you, but every once in a while, I want to get my local or public IP address. Now, when it comes to getting your public IP address, you might go to Google, do a search for what is my IP, and then get your answer there, maybe copy it to your clipboard because you want to paste it somewhere. And when it comes to using the terminal, you might do something like this, where you can do ifconfig.me. I've used this site for years. It's quite nice. I'm not going to run this one on video just because it will output my public IP address. I don't want to leak that. I also don't want to blur it on video. But if you run this one, it just outputs your IP address by itself, which is quite nice for scripting. But when it comes to getting your local IP address, that's a little bit different depending on what operating system you're using, native Linux or macOS, etc., different commands. But if you're on native Linux, you can run something like IP route list here, which is going to get a list of all of your network interfaces. In my case here, I happen to be using a wired Ethernet connection on a desktop machine here, and mine is going to be this one here, my default gateway, and my local IP address is the one that ends with .50.219. There's a couple other ones here created by Docker because I do have a couple of different Docker projects, and those are creating virtual network adapters, etc., etc. In your case, things might be a little bit different. Maybe you're using Wi-Fi, so if you're on a Linux system, this might say something like WLAN 0, and if you're using something like macOS with another command that you would run instead of this, that might be like EN0. And wouldn't it be nice though if there was just a consistent way where you can run something like myip, which is going to get both of your local IP address as well as your public. Now, in my case here, I just modified the script off camera before the video just to, fake out an output here because I just, again, don't want to have to blur my IP address all the time. So that's not my real address here. And this is going to work on macOS and Linux, which is pretty cool. There's also some flags here. You can do something like -L to get your local address here. And that is even going to copy it to your clipboard, by the way, automatically. The first command doesn't, because usually it's like if you're getting your IP address, you probably want to paste it somewhere. At least that's what I find. And then you can do -P to get your public IP address. And there is a long form flags for this as well if you want to do something like local as well as public. And if you happen to be using my dotfiles with Waybar, I even hooked it up to the network module here. So you mouse over, you get your local IP address, but I can also hit the thumb button on my mouse. That is going to copy my local IP address here to the clipboard. And then I can also hit the other thumb button on my mouse, the forward button, to copy my public IP address. And the way I remember that one is like, the thumb button that's closer to me is a local one, and the one that's further away is the one for the public one. But yeah, so let's kind of just peel back some of the layers here. The script is available on my dotfiles. We're going to go over that script at the end here, but let's go over some of the details around parsing out this information, at least on a Linux system. I found this to be pretty interesting. So here it's like, okay, this is the IP address that we want to get, but like, we can't just grab the first line here because, maybe you have a couple of different default interfaces here. And yeah, there's different commands that you can run to make sure you get the correct one. So in this case here, you can do IP route get and then 1.1.1.1. And this is going to get your active default interface here for this. Now, this happens to be 1.1.1.1, which, as you may know, is Cloudflare's public DNS server. But even before Cloudflare owned this IP address, it was typically used for things like this, where, it's a really well-known public IP address on the internet, because that's really what this command is resolving to. What interface is going to be used for whatever IP address that you put in here. So you can put in any IP address, and, for example, if we do a ping on literally example.com, we're going to get a different IP address here, this 104 one. Let's put that in and see what happens. So if we do 104.18.27.120, then we're going to get the same interface back. But if we did something different here and we did this on, let's say, one of the, internal Docker ones, we can do something like 1.72, 18.0.3, whatever, it doesn't matter. That's going to return this one here, the one that ends with 7F. Why? Because, this is, the interface related to that. So what's really interesting about this, though, is, this command is not making an external network call to this IP address. So, I was Googling around for like reliable ways to pick out your default network interface here, because I didn't want that little convenient script to, have you put in whatever interface that you have here. I want it to be dynamically figured out. So I landed on this command here, but like I wasn't convinced that this wasn't hitting the internet. So then I was like, okay, what are some ways we can test that? So it turns out using strace is a really nice way to do this one. So if we use strace here, then we can just run the same IP route get on, the same IP address here, but we're hooking up to strace. And again, this is only going to work on a Linux system here, which will then give you all the different system calls to produce the answer that it gives. Now, we can't really go over all the details of this one in the video for every single component. I don't even know those details, but I do know this. If we take a look here at this first socket call here for AF netlink, and then we take a look here at send message and receive message, all three of these things together is basically saying, hey, by the way, Linux kernel, I have this information here in send message. I'm just trying to figure out like what network interface would be used for the payload that I just provide here in the send message here. And that IP address is somewhere in here. We'll do a search for it in a sec. But then we also get a response back from the Linux kernel to be like, hey, by the way, I received what you told me, and here's the answer to that, wherever the end of this would happen to be at. But if I do a search for, I don't know, let's say 1.1.1, no, I don't want to search up. I actually want to search down, thanks. And then here we go scrolling down a little bit more, even up a little bit more. Yeah, there it is. Okay. So we can see here in the send message, then there is that information here. And then also we are in the receive message here down below, and there is the answer there, and there is the response here. We get this back. So this is pretty cool, but this demonstrates we're actually not making a public internet call because, even if you don't understand it fully, which I don't also, you can at least, at the very least, do a comparison with other tools that you do know hit the public internet. For example, instead of doing an IP route get, we can just do something like a ping. We'll ping one time, and then we'll do a ping on that same IP address. And if we do that, we get a much different output here from strace. So now, instead of that other AF, this was AF iNet. So the other one was netlink, right? So there's a difference there already. 2, this is already doing a socket connection here. So we have a connect call here, which is going to be setting up the details for this network request to the outside world. And then down here somewhere, we actually have the send to, which is as far as I know, this is the binary data that ping is actually, sending over the internet to this IP address over here. So yeah, even if we just looked at these things side by side, this is a much different pattern than what we had before. And this is really, really, really making a network call here. You can kind of think, I guess, with the IP route get one, this is almost like using GPS, I guess, with not actually going to the destination. For example, maybe you're going on a road trip somewhere and you're just sitting down on a chair somewhere in your apartment and you're like, okay, I'm going to use GPS to map out this route from A to B. And this is basically the answer that we're getting here as a response back. The GPS is giving us, the route to where we need to go. But then, when we actually do the one with ping, then that's actually, actually doing the thing. So in this case here, even if we got rid of the C1, so it pings a couple times, you can actually see here, this, I'm hitting enter a couple times so we have some spaces. Every time ping makes that network call, we can see the send to happening with the details of the results there, which is kind of neat. Pretty cool. We can even see the output of ping here as well, which again is pretty nice. So long story short, this call, what we were doing before, is actually not making an external network call. That satisfies me. That makes me happy. So now let's go over maybe parsing out the information that we actually care about, which is this IP address here. Now, you could think like, well, maybe we can just cut this one out because this is what, 6 or 7 fields over. So for example, we can do something like delimit that on spaces there, and then do something, we'll actually delimit not F, and then we're going to F on, I think it's 7. Yep. So we can also trim out the new line there, and then boom, we'd have our local IP address. But this is a little bit brittle because this output could be a little bit different depending on your network setup. Maybe you have some VPN set up or something else. And, there's different things that can make this not happen on the 7th column. So instead, what we could do is grep this out in a little bit more of a reliable way. So for this one, let me go to my dotfiles, and then we'll go to the main. Nope, my IP is actually where I want to go. I'm just going to grab this just because I don't have it memorized. And there we go. We'll go over this at the end, but yep, okay. So here we can just paste this in, and that is going to give us our IP address, which is what we want. So we're doing -o here, only matching, right? We only want to get a response back of what matched. Then we need to enable Perl regular expressions, which won't work on macOS, by the way, but it doesn't matter because the command that you run here and the information we get back is much different. So we need to parse it out much different. The script is going to handle that. But in any case here, here's a regular expression. So first of all, we know the IP address is going to come after src space. Doesn't matter how many columns are here, that is a certainty there, and this is what makes this pretty reliable. Technically, IP command can output JSON, and then you can use something like JQ, but I figured I would just roll with the grep solution here just because, it's pretty neat. So this is the keep out operator, and this is something that requires Perl regular expressions here. And what this is basically saying is, hey, by the way, I see that you wanted to match on src space. That's cool. But anything before that is not going to be returned as part of your match, which is exactly what we want. Because it's like we want to zoom right to the src space. That's what we have over here. And then we want to start capturing anything that's not a space. So we have the brackets here. That's what that's saying. This is like a negation. So anything that's not a space. And we have one or more of them. So here it's like really cool. It's like we can match all the way up to src space. and then start grabbing everything, that's not a space, that's this, 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 and this. And then it's like, hey, wait, the next character is a space. We need to stop. So we're just going to end there right at the end. And then boom, we get our IP address in a very, very nice and reliable way. So that's how all of that is wired up here to parse this out in a way that should work basically on any network setup here, which is pretty cool. So with that said, maybe now we can take a look here at the script to see how it helps us a little bit. So the script here, yeah, it's all set up. It's available in my .files if you want to check it out. So here it's like, okay, you can pass in a flag, right? So the flag can either be, -L or the long version, same thing with -P, or you can pass in no flag, or, you pass in something invalid. It's going to, fail out here. So in this case here with the local one, we're just going to run the local IP function, which we'll go over in a sec. Likewise for the public one, we're going to do the public function instead. And then we're also going to pipe those to clip copy, which is a nice little script I have here, which just lets you do basically copying to your clipboard in a cross OS compatible way. Even different display servers, it starts trying to do Wayland here. If not, it falls back to something that should work on macOS. And then finally X Windows over here. So if we go back to here, that's basically how that's happening. But yeah, okay, let's maybe take a look at some of these functions here. So let's start with the public IP address one, just because it's a little bit easier. Here's the real curl command. And then in my case here, I just did printf here because this is exactly how curl is going to return it here. There is no new line at the end of this curl output. That's why I'm echoing a new line here, just so it gets printed to your terminal nicely instead of just seeing that little % symbol there with not a new line. But I also made the script a little bit more robust here because, if you have an IPv6 address, then it might return that. So in this case here, we're forcing IPv4. Also, I just set the max time to be 3 seconds here because, if for whatever reason this website's experiencing downtime, or maybe your network connection is messed up and you're using this script in some automated way, the worst case scenario here, it's going to wait 3 full seconds here before curl is going to give up. And then you'll just get, a failure here, basically. Actually, what should be done here maybe is just putting a fail here, which would be even better because we do have set E here being set to where if this fails, then yeah, we wouldn't even get to the point where the rest of the script continues. In this case here, obviously this line wouldn't be here in the real script. It would just be the curl command by itself. But in any case here, it would be nice to maybe fail and now output anything instead of just getting whatever the heck this would return here if it failed here with a timeout or something like that, like some response from curl. But in any case, cool, I'll make that adjustment here after the video. The next one is the local IP address, where we first need to see hey, by the way, are we running Linux? So if you're using Bash or Z Shell here, which we are using Bash in the script here, then OS type is going to be available. This will just return Linux GNU, I think. So let me go and just maybe do an echo for OS type that will be defined here. And then we have, Linux GNU. So that's a really nice way just to very quickly see, hey, by the way, running Linux or not. If you're on macOS, it's Darwin. And then I think maybe the major release or something like that, there's some number after it. So yeah, in this case here, I want to support all the different ones. So that's why I put a star there. But yeah, it's okay, cool. Here's the one for, Linux. That command we just went through in the other window here. It's doing the same exact thing. And then on macOS, yeah, we're running ipconfig and then basically the same type of thing, right? It's we're using route n and then we're getting this one here. And then instead of just being able to parse it out with grep there, because again, this output is much, much different, we are using awk here to grab out basically EN0 or whatever your adapter might happen to be here, passing it into this, and then we're getting what we want out. I understand it's pretty hand wavy here. I don't have macOS to do a screen share, but the good news is, in the blog post here, I did go on my company issued MacBook Pro here. I ran some commands to get the outputs here. So we can actually see what the heck this actually translates to. So on macOS, if you were to run this route command just like this, then you would get the output that you see here. And then in this case here, we want to grab that interface line with awk here and just get the second value here, the EN0, which would give us the answer that we want here. So yeah, all awk is doing there is extracting out that EN0 basically, just to be able to pass it into this command here. And that's going to give you the IP address. It's kind of interesting because I have that MacBook Pro set up to where it is on a completely different guest network instead of my main network, just because I want to keep it isolated. So that's why it's on a different IP address here versus the one that we saw here in the other response. But yeah, that's basically the script here. Again, it's in my dotfiles if you want to go and check it out. So you can always find this up on GitHub here. If you go over to the local or the .local bin directory, there's all sorts of different things here, but one of them is this my IP script here. And by the time that you watch this video, I will push it up with the fail flag here, just because, yeah, I feel like that is a good idea. You can see here too, the real script doesn't have that little print there. And actually, if we go back to here, again, I can just bring this back to what it was before, and you'll see no git diff once I remove the fail flag here. This is the original state of the file. Let's bring that fail flag back, and we'll do this. And then there it is. And we can see like, cool, this line changed. But yeah, any case here, if you have any questions about any of this, let me know in the comments below. I'll do my best to answer all of them. If you liked the video, please give it a thumbs up. It really does help a lot. Thanks a lot for watching, and I'll see you in the next one.